Good afternoon, students. Today in this lecture talk, let us discuss on significance of baffles. Okay, as you can see here, these are the baffles which are present inner wall of the fermenter vessel vertically. Okay, this is the impeller central shaft, and these are the baffles. Now let us understand here what are these baffles, what are their functions, types. Okay, why basically these baffles are kept. Baffles are vertical plates or strips installed radially along the inner walls of a cylindrical bioreactor vessel. All right. They play a critical role in optimizing the mixing efficiency and overall performance of the bioreactor, particularly in stirred tank reactors where the impellers are used for agitation. Okay, I hope you understood the position of the baffles, right? And where exactly these baffles are present and for what purpose. All right. As you can see here, see this is the big bioreactor vessel where man has went inside to check or verify something through this temporary ladder. And these are the baffles. As you can see, this is the baffles and this is the impeller and this is the central shaft. Okay, I hope you understood about this particular position of the baffles. All right. So now let us go through the primary functions of baffles. The primary function of baffle, the first one, prevent vortex formation, or this particular baffles which prevent the swirling. Okay, without baffles, the rotation of the impeller would primarily cause the entire liquid mass to swirl around the vessel, creating a central vortex. So central vortex in the sense that is like a, in Kannada what we say ಸುಳಿ. ಈಗ ಜೋರಾಗಿ ಏನಾದ್ರು ತುಂಬಾ ನೀರ್ ಬಂದಾಗ ನದಿಗಳಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ ಸುಳಿ ಬಂದಿದೆ ಅಂತ ಹೇಳ್ತೇವೆ. ಸುಳಿ ಬಂದಾಗ ಸೆಂಟ್ರಲ್ ಅಲ್ಲಿ ಹೋಗ್ಬಿಟ್ಟು ಎಲ್ಲ ಸೇರ್ಕೊಳ್ಳುತ್ತೆ. ಏನಾಗುತ್ತೆ ಅವಾಗ ಈ ಮೈಕ್ರೋ ಆರ್ಗಾನಿಸಮ್ಸ್ ಎಲ್ಲ ಅನೇಬಲ್ ಟು ಗ್ರೋ properly and uniform distribution of the nutrient, heat and the pH and the aeration is not possible. Mixing is also not possible. So to prevent the vortex formation, to prevent the swirling, there will be the presence of the baffles. This vortexing action leads to poor top to bottom mixing and reduces the incorporation of surface gas, that is like oxygen bubbles, into the liquid medium. That's why these baffles are kept in the inner wall of the fermenter vessel. Baffles disrupt this circular flow pattern uniformly. I hope you understood this primary function of the baffle, that is to prevent the vortex formation or to prevent the swirling. Next, this baffles enhance mixing by impeding the swirling motion. Okay, baffles promote turbulent flow within the bioreactor. This turbulence leads to more effective mixing of the culture medium, ensuring uniform distribution of the nutrients, oxygen, temperature, and also the pH. The nutrients like providing all microorganisms or cells with equal access to the necessary food source. This is very much needed for the organisms for their metabolic reactions, like production of the metabolite, primary metabolites, secondary metabolites, and about the final products. Then oxygen here, the baffles facilitating the transfer of oxygen from the sparged gas bubbles throughout the liquid. Then this baffles also responsible for maintaining a consistent temperature profile within the vessel from the top to the bottom, from bottom to the top. Then this also ensure uniform pH distribution. So in general, together, all we can say these baffles enhance mixing of nutrients, oxygen, temperature, and pH. All right. The next function, increase aeration efficiency. By breaking up the swirling flow, baffles increase the residence time of gas bubbles in the liquid and enhance the gas-liquid interfacial area that leads to the improved oxygen transfer rates, and also microorganisms will be very happily receive the nutrients, temperature, pH, and oxygen concentration. And we are able to get the good product. The next function here is increase power input to the agitator. Baffles increase the resistance to the impeller's rotation, which in turn increases the power required by the agitator motor for a given speed. This increased power input is effectively transferred to the liquid as mixing energy. That's why mixing is very important in the liquid fermenter vessel. This also improves heat transfer, that is enhanced mixing due to baffles also contributes to better heat transfer throughout the bioreactor. And this is also crucial for maintaining the optimal temperature for the culture. And the next one is reduce mechanical stress by preventing a strong centralized vortex. Baffles can help to reduce excessive stress on the impeller shaft and bearings. Okay, and stabilize fluid motion. This baffles helps to create more predictable and stable flow patterns within the bioreactor. Okay, that gives about the stability of the fluid motion. And next, let us go through here about the types of baffles. Under this types of baffles, well, the standard design involves flat vertical plates. Variations also exist based on specific bioreactor designs and applications. It's not like one type of baffle. There are so many other different types of baffles are there. Students, and here, if you find like too much information, we can just make a key points, okay, and you can write that one. Usually you may get regarding baffles about 2 marks or maybe 4 marks. That's it, okay. For 2 marks and for the 5 marks, you get ready from this particular chapter, okay. Standard flat baffles are also available, which are typically 4 equally spaced vertical plates attached to the vessel wall and extending from just above the bottom, just below the liquid surface. The width of the baffle is usually about 1/10 to 1/12 of the vessel diameter. All right. Then finger baffles or tie rod baffles are also available. These are supported from the top head of the reactor and may be used in glass-lined vessels where direct attachment to the wall is challenging. Another baffles like H baffles, a variation of finger baffles with the horizontal cross piece for added stability. Next one is disc head baffles are there, which are used in vessels with the disc bottoms to improve the mixing in that particular region. Then even we have bottom mounted baffles, which is crucifix baffles, which are used with the axial flow impellers to prevent swirling at the bottom of the tank. Then we also find helical baffles. These are twisted baffles that can promote a more axial flow pattern in viscous liquids. Then coming to the another types of baffles like baffle cages. Some designs incorporate cages around the baffles for added support of specific flow modification. So another baffle like integral baffles. These are built into the vessel wall design itself. Okay, so these are some of the different types of baffles which we come across in the fermenter vessel. Now let us focus on design consideration for baffles. Number of baffles in the fermenter vessel vary according to the product formation or the mindset of that particular industry. Typically, 3 to 6 baffles are used, with 4 being the most common. 3 to 6 means 4 is the most optimized one. Increasing the number of beyond this usually does not significantly improve the proper mixing of the content or any kind of sources which are present in the fermenter vessel. Coming to the baffle width, as mentioned, usually 1/10 to 1/12 of the vessel diameter is always acceptable with the baffle width. Then coming to the baffle length, typically extends from just above the bottom to just below the liquid surface to avoid interfering with the settling or foaming. Then distance from the wall, the baffles are usually mounted slightly off the vessel wall. For example, at a distance of 1/72nd to 1/50th of the vessel diameter to prevent stagnant zone behind them. Okay, to conclude, baffles are essential internal components of most sealed tank bioreactors. They significantly enhance mixing, aeration, and overall process efficiency by disrupting swirling flow and promoting turbulence. Okay, ultimately leading to better growth and productivity of the cultured microorganisms or cells. Okay, this is all about the baffles. I hope you understood the baffle content. From the beginning, we went through about the water baffles. Okay, so and the definition. Then we also went through about the primary functions of baffles, like that prevent the vortex formation, then enhance mixing of nutrients, oxygen, temperature, pH, right? And also the increase aeration efficiency, increase power input to the agitator, improve heat transfer, reduce mechanical stress, stabilize the fluid motion. Then coming to the types of baffles, we have a standard flat baffles, finger baffles, H baffles, disc head baffles, bottom mounted baffles, helical baffles, baffle, cages, and finally integral baffles. When coming to the design and consideration for baffles, one has to think about the baffle width, baffle length, and distance from the wall. So this is all about this is all about the baffles which are used in the bioreactor or fermenter vessel. I hope I made myself clear about the baffles, functions, types, and their importance. Thank you everyone for watching this video. Stay tuned with me for more information. Thank you all.